All right, what's up, everybody? Welcome to the next video. This is for topic 4.3. We're still working with chemical reactions. We have looked at the different types of reactions, how to predict reaction products of single and double replacement reactions based on the reactants, right? How to predict those products. And so what we're going to do today is sort of the next step um, in our long-term goal, which is to know how to completely work with chemical equations. One other thing that we need to learn how to do is how to balance chemical equations, okay? So I don't really have any notes for this because, once again, just like with predicting the products, there's not really any notes that you need. It's more of a skill that we're going to be practicing. Um, and so I'm just going to be working with the whiteboard here. I will go ahead and write the title here for you, though. Okay, so balancing chemical equations. Um, Before I really get into showing you how to do this, let's just talk about chemical equations in the first place. Okay, so let's see here. Let's take a chemical reaction like this. Let's say we have some potassium metal that is exposed to chlorine gas, which takes the form of Cl2, okay, to form a new compound. This is a synthesis reaction. The new compound is an ionic compound, potassium chloride, KCl. Okay, so we have pure sodium metal exposed to chlorine gas, and the synthesis reaction takes place, forming this new compound, potassium chloride. All right, so let's say I give you this equation. All right, what we're going to be learning how to do right now, and in class when I see you on Thursday or Friday, is how to balance these equations. What do I mean by balance? Well, some of you may have already sort of noticed this in the past, but if you haven't, let me show you. This equation right now is currently unbalanced. Okay, and what do I mean by that? Well, what I mean by that is if I look at each element on both sides of the equation, there is an unbalance. Okay, so I have one potassium on each side, so that's actually balanced. Okay, but I have two chlorines on the left compared to just one on the right. That is the unbalanced aspect of this equation. Okay, why is this important? Like, why can't it be unbalanced? Why do we have to balance it? Well, there is this thing called the law of conservation of mass. Okay, and what that says is that you can't create or destroy mass, or in this case, atoms. You can't just create or destroy them. You can move around their orientation, you can change their configuration, such as in a chemical reaction, okay? But you can't just eliminate them altogether, okay? So in reality, if we have potassium plus chlorine gas, Cl2, the chlorine can't just disappear, okay? So what we are going to do is we are going to add in some numbers which are called coefficients. Okay, so I'm going to draw some blank spots here. We're going to add in some numbers that are going to fill in these blank spots here that are going to balance the equation for us. Okay, and I'm going to show you how to do this a couple of different ways. I'm going to show it to you sort of visually, and hopefully it really sort of drives it home. Okay, so first thing I'm going to do is I'm going to actually use a little bit of a different color for each of my ingredients here. So let's see. Let me actually back things up a little bit. Let me use blue for everything right now. Okay. All right. Let me use green for potassium. Okay, for no particular reason. All right. So I'm going to use green for potassium, and I'll use red for chlorine. Okay. All right. Can you tell that I was not an art major? This doesn't quite look as good as I would wish. All right, good enough. Okay, so here's what we've got. On the right side, right now, okay, we're going to assume right now that we have one of everything, okay? Now, when I say one of everything, I mean that we have one potassium, one Cl2 molecule, okay, so this would really be two chlorines, and then one potassium chloride, 1 unit of potassium chloride. We're going to assume that these coefficients are 1, okay? Now, that's not going to be the final answer. We just talked about how the fact that this is unbalanced, right? I have 2 chlorines on the left versus 1 on the right. But to start, we're just going to assume that we have one of everything. Okay, that's going to be sort of our starting point. What I'm going to do then is I'm going to draw what this would look like. Okay, so like in real life. So here is my potassium atom. I'm just going to label it with a K. Okay. Then I have my diatomic chlorine, my 2 chlorine molecules. Sorry, my 2 chlorine atoms that they're covalently bonded together, but I'm just going to draw them like this for right now. Okay, so that is 1 Cl2. All right, and then over here on the right side, I've got my potassium chloride. This would be an ionic compound. Okay, but we don't really need to worry too much about those details. All I need to do is just draw it. Okay, 1 potassium with 1 chlorine. Technically here the potassium would have a positive charge, chlorine would have a negative charge, but like I said, that part doesn't really matter to us for this specific skill. Okay, all we're really concerned with is the number of these different things. Okay, now these should be equal. Okay, I should have equal amounts of stuff on the left as I do on the right. I'm not allowed to create or destroy atoms. Okay, that doesn't happen. So what we can do here is we can change these coefficients to discover what really happens in nature. Okay? If this reaction really occurred, we wouldn't have one of everything. Okay? Let me show you. Okay? So let's see. I have 2 chlorines here on the left side, right? Well, if KCl is my product, I must create 2 KCl's, or at least 2, right? Oh, let me draw that connected like I did in the top one here. Okay, if I start with 1 Cl2, 2 chlorine atoms, I must create at least 2 KCl's. What that means is that this coefficient must be a 2, okay? So for every 1 Cl2 that you use, or that it gets consumed in your reaction, you're creating 2 potassium chlorides. Okay, you have to, because you have 2 chlorines to start. You've got to have 2 chlorines to finish. Okay, you got 2 chlorines going in. You got to have 2 chlorines coming out. Okay, now what that also means is that in order for this reaction to be balanced, okay, in order to sort of discover what is really going on in real life, if I have 2 potassium chlorides here on the right side, I must have started with 2 potassium atoms as well, okay? Which means that this coefficient must also be a 2, okay? This is the balanced equation. 2 potassium atoms plus 1 diatomic chlorine molecule will make 2 potassium chlorides, okay? This is the balanced equation. What we are doing today is we are learning how to come up with these numbers. Okay? I'm going to be giving you guys a list of lots of different equations that have blanks in front of them, in front of each ingredient, so no numbers, and it's going to be your job to figure out what those numbers should be. Okay? Let's look at one more example here. Let me do one that is sort of middle of the road. We don't want to get too difficult, but we'll step things up a little bit here. So let me clear this out. Let's take a look at this equation. So let's say we have P4. This is like just molecular phosphorus, so just like pure phosphorus, plus O2, so oxygen gas. and this is making a compound, this is making a compound P2O3, okay? Now, I'm not going to get all fancy with the colors this time because that takes a bit too long. But what I'm going to do here, okay, is I'm going to once again show you how to sort of visually approach this, right? Let's assume that we have one of everything, okay? That would be 4 P's, okay? So I'm really sort of taking some shortcuts here. I'm just going to group them all together like that, all right? 4 P's, 2 O's, and on the right side here, I have a P2 and an O3, this compound, P2O3. So I'm just going to write PPOOO. Okay. Once again, here's where my equal sign should be. Some people even like to draw a line through the arrow to sort of divide the problem into 2 halves. That sort of helps them sort of see what, the 2 different sides here. You can do that or not. It's sort of up to you. Okay, so what I see here is that currently my equation is unbalanced, right? I'm starting with 4 phosphoruses, but I'm only ending with 2. And I'm starting with 2 oxygens, but somehow I'm ending with 3. So what this tells me is that these coefficients can't be right. There must be other numbers that go here to balance the equation, to tell us what actually is happening in real life when this reaction takes place, okay? So how do we go about fixing this? Well, you sort of have to pick one of these elements and just fix it, right? And then take a look at the other. Both of them are unbalanced, right? The P's and the O's are both unbalanced. So me personally, when I look at this, I see that I have 4 phosphoruses versus 2. Well, if I change this coefficient here to a 2, meaning I have 2 P2O3s, 2 of this compound here, then I've fixed my phosphoruses, right? I have 4 on the left, and I have a total of 1, 2, 3, 4 on the right. My phosphoruses are good to go, okay? What about the oxygens then? Okay, well, I have 6 oxygens on the right side now, 6, right? 3 here and 3 here. So I can achieve 6 oxygens by adding 2 additional sets of O2, changing this coefficient from a 1 to a 3, okay? So this would be the balanced equation. 1 P4 plus 3 O2 creates or produces 2 P2O3. This is what happens in real life when this reaction takes place. 4 phosphorus atoms are used up with 3 molecules of oxygen, of O2, to create 2 P2O3s. You could not do, nature will not do 1 of this plus 1 of this, making 1 of this. That can't happen. So that's what we're trying to do today, right? We're trying to figure out what are the numbers that go here that represent what's actually happening in reality. What's actually happening that obeys that law of conservation of mass, okay? All right, so thanks for watching. We're going to be doing a lot of problems like this. We'll do some additional practice when you come into class on Thursday or Friday morning, and then you'll have some additional problems to practice on during our asynchronous time, okay? Thanks a lot for watching, and I'll see you guys next time.